Hey everybody, welcome to PC Perspective. I am Ryan Schrout here today with an interview on an interesting topic, something that has actually been coming up quite a bit over the last handful of years. I'm here with Bruce Dell, the CEO at Euclideon, who is, I guess we're going to talk again kind of about your unlimited detail engine. You guys are releasing a new video that's kind of promoting some of the new features and capabilities that you guys have built into it. And it's been a while since we've last kind of heard from you guys. I think it was like 2011 or 2012, right, where we first kind of saw the island demo and some of that type of stuff. What have you guys been doing since then?
Our new video is what we're doing in the virtual reality race at the moment. I think everyone's getting into virtual reality, and we always like to be a little bit different. So I think while everyone else has been pursuing virtual reality helmets with screens over your eyes, we went to the other form of virtual reality, which is virtual reality caves, normally very big, very expensive, millions of dollars normally. And decided to see what would happen if instead of having a virtual reality cave on 80 computers, we hooked in our unlimited power algorithm we put it on one computer to see if we could get a virtual reality cave running at a fraction of the computing power. It was a complete success, and as strange as it sounds, we've now got the largest number of virtual reality caves. I think there's about 120 virtual reality caves in the world at any one time, in science centers, universities, things like that. We've built 40 virtual reality caves, hologram rooms, and we've opened up the world's first hologram room entertainment center where people go into virtual reality caves. If you've never experienced that it's something most people never have any access to. No. I know in England, they made a virtual reality cave for, I think it was $15 million. Fraunhofer, which is the main science group in Germany, they showed last year they'd made one for only 1.2 million euros. So normally this is stuff that ordinary people don't get access to, but they're really exciting. When you see something like an elephant or something appear in front of you that looks like it's made of light, and you can walk all around it and then put your hand straight through it, it sort of makes you go, wow, this is something I've been waiting for. This is something science fiction's promised me for 20 years. And right. And I've been waiting for it, and now it's finally here. So that's what we've been doing. Opened up, I don't know what you call it, hologram entertainment center. Right. And we're now about to expand these all over the world.
That's pretty cool stuff. I actually... I'm a little bit jealous. There are none of those in the United States yet, correct?
There are none in the United States, but we can move pretty quickly. Okay. Give us a bit of time. They'll be there really fast.
All right. So I want to give everybody, I'm going to go through a little bit of background on the technical side of things about kind of how you got to this point, right? So what Euclideon was really known for was 3D engine or 3D graphics system that was not based on polygons, and instead it was based on what you guys call atoms, or what some other people call point clouds, or might also be called voxels, those types of things. What is, and then also I guess the important part here is that you were claiming that you could have trillions of these atoms, trillions of these voxels in a single scene, and you could scale in and out to them without having to, performance degradation. How is that possible for you guys to do that on the PCs of today? Basically to translate the idea of trillions of points that equate to, I don't know, trillions of polygons, maybe hundreds of billions of polygons into a single system, but still maintain performance levels.
Yes. I understand certainly from where everyone is today in 3D graphics, that must seem impossible. Whenever we use the word unlimited in anything to do with computers, people go, no, a computer takes time to process each thing. So how is it possible that you're showing this scene with trillions of very, very complicated objects? But I suppose in the polygon system, if I put one object, say it's a tree, on the screen, and then I put a second one, the first one uses up this much processing power, The second one uses up this much processing power. So with the polygon race increasing each year at about 27%, with computer graphics cards slowly getting better, people understand that as computers get better and stronger, you get more polygons, you get more geometry.
Okay.
Now, if you try to build things out of point cloud data or little atoms, I mean, when you say point cloud data, 99% of people aren't familiar with that term, but
True.
An atom, they know what that is. They got taught that at school. So when we build things out of little atoms, it's a lot worse. If every atom the computer has to work out where it goes on the screen, and your X, Y, Z dealing with trillions of these, then once again, the problem becomes even worse. But if you have a way, because if you think about it, if I build a forest out of atoms, how wasteful. All the trees at the back have been covered by the trees at the front.
Right.
So if you have a way of grabbing exactly one atom for every pixel on the screen, then there's one cost. Very different to the polygon system, where it's the more you have, the more it costs you. If you can get one atom for every pixel on the screen, and that requires a three-dimensional search algorithm, just like Google or Yahoo go looking for words on the internet. A lot of people tried, we were the first ones to actually get it right, to build a three-dimensional search algorithm which can work out exactly which are the atoms that need to go on the screen. Mm-hmm. It's not the first time people have had that goal. Back about, 8 years ago, a lot of people were chasing ray tracing, which is sending lines through the air, and would give you a very similar result. Intel announced that they were going to try and take on NVIDIA and AMD with their Larrabee ray tracing card. Yeah. But in the end, ray tracing was too slow. Sending little lines and then grabbing something, whilst it gives you the same result, one atom for every pixel on the screen, the ray tracing process was something where even with the best hardware, no one was able to get anything that they found to be an acceptable replacement for polygons. We showed there's a very, very different way to go searching and get that same result of one atom for every pixel on the screen. But this way is so efficient and so fast. In fact, it doesn't even use basic maths. There's no multiply and no division in the core of the system, which is like 99.9%. We found a really, really different way of doing things, but it gives that same result of zero waste, one cost, regardless of the amount of geometry or the amount of objects on your screen.
So that's more or less kind of replacing the idea of a projection into like a traditional 3D polygon-based world, right? Where you're doing a 3D search to try to generate what actual atoms and points you actually see. Now, how do you do things like, prevent aliasing or prevent, how do you do like color merges and stuff like that for colors or points that may be very close together that overlap on screen pixels, that type of thing?
Well, I could go into the details of it all, but in every case, if you put yourself in our shoes, what we started with was something where we said, wow, this is really good, but look how much it lacks. The distance between what we begin with to the point where we've got anti-aliasing, we've got animation, we've got lighting, all of these things. So the best way to describe our company is that we did something that most people would have thought was a bit strange. We said, we're going to bulldoze down the existing 3D system and say, let's rebuild absolutely everything. Because once you say, I'm going to build my animations out of point cloud data, you can't use existing animation tools. They weren't made to build that.
Right.
There's so many things you can't do. So for every single thing that in polygons, we had to create a totally different way that had almost exactly the same visual result. So it's been a lot of work. We're a reasonably small team. And I think we're just starting to get to the point now where people are saying, hey, this is comparable to some AAA games on the market, even if we're talking the StarCraft, Mario type end. Mm-hmm. But you can see in the video also our technology for copying the real world. Right. And so I think at the moment what you're seeing is we're just entering showing this sort of technology is comparable to some games today. But with what we've achieved in such a short time, I think you're about to see sort of this swoop past everyone, take over, as we start to integrate in that technology that can make 100% copies of the real world that we'll be showing in the video.
Now, one other interesting thing that some people may not be comprehending what's going on, all this is done on the CPU, right? This is not a GPU-based task, right? Is there a reason for that? Because, my initial thought for many people might be, hey, this is highly parallel workloads. This should work well on a GPU, but you're actually running this on the primary CPU, right?
So originally we made it on the CPU, and we said, well, it makes sense that we should rebuild this on the GPU. But when we were doing the same sort of resolutions as you see in most games, when we moved to a hologram room, 3,800 resolution, and we have to make it twice for both eyes, fast enough for it to be functioning without any latency.
Right.
At the moment, I know this sounds very strange, but we just sort of said we've got more important things to do than put it on the GPU until we see what looks like we need that extra power. If we start going to 4K screens, yes, I think we probably will go to the GPU. But at this particular point in time, there's just been other things that have been more important to us when what we're running on the CPU seems to be doing the job.
Are there any memory footprint concerns for this as well? Like, typical graphics card, a high-end card would have 8 gigs of memory, but system memory might have 16 or 32 gigs. Is there an advantage or disadvantage there?
So the other thing that we do, and if you go to the Euclideon channel, you have to watch the geospatial videos, which is like 3D mapping. We haven't really pushed this technology. We've made so many different things. If we push them all, I think people get a bit confused. We built a system for streaming straight from the hard drive. So to try and make that a little bit simple, normally loading is the act of taking from the hard drive and putting into the computer's RAM. So if I'm listening to music, it can load from the hard drive while I listen to it, because it's like a nice big straight line. Okay. If I watch a video, it can load from the hard drive while I'm watching it. But when you're dealing with 3D graphics, the reason why your games say, loading, please wait, just wait a little bit, or you see things in the distance sort of pop up as they're loading in, is because in 3D graphics, it's not a straight line. It has to say the mountains in the distance, they're over here, the trees up close, they're over here, and it jumps around the hard drive. RAM is called RAM, random access memory, because it can be randomly accessed, meaning it could be accessed anywhere. A hard drive is different to that. So we've actually come up with a new way of structuring the data where it streams off the hard drive. Originally, a lot of people said, you cannot do that. It does not make any sense. But we did examples where we were showing 3 terabyte models. We did a 3 terabyte model of the city of Vienna at one of the SPA conference, one of the largest conferences for laser scanning in the world, where we took a 3 terabyte model, hooked it into a $600 laptop, and in 0.8 seconds there we were flying around without any sort of artifacts of any kind. We even then moved to little USB sticks. They're not fast, plugging them in and instantly running. So whereas you normally think in terms of how much RAM does this take, because hard drive space is as cheap as can be. Right. I don't know what to pay there. We pay about $50 for 3 terabytes. I really don't know where we're up to on that. But hard drive space is very cheap.
Yeah, definitely.
We don't really have that concept anymore of we need lots of RAM when we don't even load.
Huh. Okay. So that's it's an interesting dive into kind of like the engine side of it. I know when we last talked and when we last kind of looked at what Euclideon was doing, everything was very static. We didn't really have animations yet. We didn't have characters. We didn't have things like that. You talked about in this most recent video the difference between artistically good graphics and technically good graphics, and then you go into the animation side of things. Obviously, from a technical standpoint, the idea is you believe that the Euclideon engine kind of solves the technical side of things because you don't have to worry about polygon counts and polygon limits for specific sections, or having to worry about different quality levels for different GPUs and that type of stuff. And then in the artistic side, you've mentioned it several times here, the idea of the laser scan to bring real-world objects that are scanned through laser scanning with these point cloud systems, and then using kind of a proprietary system you have to combine those points, solidify them, and make actual objects out of them. How much massaging do you have to do to something that is 3D scanned to actually get it into a game, do you think?
Yeah, so in the past, when laser scanners were first invented, naturally people all said, wow, can we use this laser scanner to make things for our game? So there was a lot of experiments in the early days where people would laser scan a room, and then they would say, how do we now turn this into polygons so we can use it? Because you certainly can't use the amount of data that you would get from a laser scan when everything's made of little points like that, not before we came along. So people would try polygon meshing, and they would, once they polygon meshed it, they'd say, okay, well, we've got however many billion polygons here, we can't handle this. So we need to start downscaling. So artists would go through. I know recently there was some games using photogrammetry that made very, very realistic graphics. And in some cases, the companies swore, we will never do that again. Because when you take something like a rock and you start with however many billion polygons, and then your artists have to start removing vertices and cutting it all down, but still going, what's the best way to remove these, but still have the basic shape be there? It ends up being slower than if they just made a rock. So always when it comes to copying the real world, the games industry says, no, we'll just build it ourselves with really good artists that make things look really realistic, because there's too much massaging to bring it from something with lots of detail down to something that's got a lot less detail but still looks good. In our case, when we encountered laser scanning, we said, well, it's full of holes. I don't know if you've ever seen a laser scan, but when things are made of dots, it looks like termites have eaten it. So we changed the format so that it makes like a skin of atoms. So think of it like polygons, as in it's a skin of atoms, still hollow on the inside, like chocolate Easter rabbits. And because we can run that, there is no massaging, there is no downscaling, there's nothing to do. You scan, you bring in, you use as much as you like. When artists first join Euclideon, we say, here's an unlimited power level editor. Here's, some really interesting piece of grass with rocks or whatever. Just copy that 8 times, and I'll copy paste that 8 times, and I'll copy paste that. And soon they start running into using whole fields of stuff where an individual little group of rocks wouldn't be able to be run by the standards that they're used to. They always feel a bit naughty at first, like, oh dear, I'm so used to polygon budgets. I'm like a beaten puppy who's finally found freedom to do whatever I want. It takes them a little while to adjust to that. Use what you like. There is no memory limits here. We stream from hard drives. There is no polygon budget here.
Interesting. Now, that's how you could get like a static object, but let's talk about animation some. I assume, you mentioned this earlier, that pretty much all the tools that exist for creating animations were built for polygonal structures, right? So did you have to create these tools themselves? And kind of, if you're a game developer, if you're an aspiring game developer, you're looking at these tools and getting excited, how complex is it to create animations on these point cloud systems, these atom-based models, as opposed to what they may be used to with polygons?
So in reality, I suppose we're being a little bit defiant in all of this. There is no trouble in taking polygon animated characters and having them run in unlimited detail backgrounds. We showed long ago that we can take unlimited detail and make the Z depth that the graphics card wants, and then you can put on characters over the top. And so a lot of people said, just stop there. Use unlimited detail for the backgrounds, polygons for the characters, everyone's happy. We went, no, people are putting limits on us. We don't like that. We will keep going forward. So there is always that fallback position, if anyone wants to use it, of just putting polygon characters over the top. But we said, we are going to show that point cloud animated characters are something which is doable. Everyone said they were impossible. In the video, we show a snail coming out of a shell. And the reason for that is people decided that with point cloud data, you can probably do what we call skeletal animation, which is where your sections of your body are all sort of separate pieces, and then you put them together, and we have the animated tools to sort of make them move around. And yes, we're using skeletal animation, but also skeletal animation where the objects can stretch, where they can melt, where they can do a lot more than just like act like a robot. So we snail sort of doing this into his shell type thing to show whereabouts we were up to. The advantage of making things out of point cloud data is the textures are real. If you look at the snail and you see sort of bumps and things on him, then those are real bumps. They're not a flat picture on your polygons. And normally that doesn't matter when we're looking on 2D screens. If I go up on a 2D screen to a flat brick wall, it looks pretty good on my 2D screen. But as soon as you go to virtual reality, we show in the new video we've made the problem that even Oculus Rift is talking about how in virtual reality, a texture on a polygon that convinces us on a 2D screen does not convince us in virtual reality. People look at it and they go, it looks like a cardboard painting, because you don't, in virtual reality, you've got two eyes. And so you get that sense of depth, what is closer and what is further away.
Right. And
so you, with that sense of depth, in the words of what's his name? Michael Abrash?
Michael Abrash,
CTO. Yeah. In his words, in virtual reality, polygons look like a cheesy stage shot, and says we're going to need a whole lot more before we can start getting that real geometry. So for us with the animated characters, by making that a point cloud data, you get that real texture on them, and they look a lot more realistic than flat polygon textures. So yeah, we had to rebuild all our own animation tools, and they're okay. They're pretty good. I don't think anyone's complaining. There's better animation on the way. We're moving on from skeletal animation to other forms that are a lot more bendy, but it's for the user. It's pretty much business as usual. We've tried to sort of be as close as possible to the way that animation is done in the existing tools and the way we've made our tools.
I assume that, you guys are basically kind of working this solo at this point, right? So in the polygonal world, you have the 3D studios and the Epics and all these guys, all these different companies working together to create these specific tools for animation and lighting and shadow effects and all this other type of stuff. Is it something that you feel you will have to do eventually, is kind of partner with some of these companies that start to see the advantages of the unlimited detail engine and say, okay, we want to help build tools for that? Or is this going to be a solo facing project for the foreseeable future?
I remember when we first brought out the Euclideon Island demonstration, a popular comment was, good luck getting everyone to leave polygons. The reality was we were contacted by, without exaggeration, I would say a third of the major game studios. And they would show us things like, I can't name them,
sure,
these emails in confidence, but they would show us things like, here in this game, we had to build this tree 8 times. This is the high detail one for when we're close. This is the one for when we're a little bit further away. This is one for a little bit further away, etc., etc. And then they show, as you move in, click, click, click between the different models. They say, when is this available? When can we use it right away? And at that particular point in time, we felt like we could go down the road of releasing a game engine. And we had our reasons financially for temporarily going off track into the geospatial industry. So sure, the geospatial industry is where they laser scan in whole cities.
Right.
They also use cloud data. And there's a lot of big places around the world now, I don't know if I am or aren't allowed to name them, that now use the unlimited detail engine. Look, the ones I can name without going into military would be French Railways now. They run the French railway system, a great big model of the whole thing on unlimited detail. The largest geospatial corporation in Europe, Hexagon Corporation, they use our technology now. They've licensed it. The Hungarian government? They put up all these models of how they've laser scanned every railway track, every building, every road, been driving all over Budapest. They can run the whole thing on tiny little laptops now. Terabytes and terabytes and terabytes of data. So we sort of went off for a little while, off track. We said, there's the geospatial industry has got great big point cloud data. They need us a lot more, and it's a lot easier. It's the low-hanging fruit, easier to take. But we've done that. It's gone well. And we said, okay, well, back to games. Oh, look, you're all headed off to VR now. Well, we'll decide how we're following in that. At this particular point in time, I think it's probably about time now where we're ready to seriously talk our alliances in the games industry and the VR industry.
Yeah, I mean, from my perspective, again, and I'm sure you felt this from the first day you posted a video and started talking about your technology, is that it needs to be seen and played with to be believed ultimately, whether it be by the public, whether it be by developers, whether it be by tool creators, those types of things. Is it? You talked about the hologram based systems that you've put together, and that's kind of like the first place where people can get their hands on it. Do you plan on doing things like in this new video, you can play this on a 2D flat screen, right? Is that something you want to release a demo of, that you want to like show people that they can interact with and give some kind of preview of that kind of stuff?
So, yes, whilst now people can just walk into Holoverse and see unlimited detail and play it all holographically, which is all very nice.
Right.
Okay, people ask, how is this one company inventing so much? But there's a simple answer. Once you've got unlimited power, it's like being able to say there's all these things that people could have done in the future when computers are stronger that we can now do today. With the copying the real world, it wasn't the copying the real world that was the problem. It was, how on earth do you run a skin of atoms of a real copy of the real world with all of its detail? So a lot of this is about sort of grabbing things from the future and bringing them to today. And so a little while ago, earlier this year, we released more to the geospatial industry, but plenty of game people caught onto it as well.
Yeah.
A streaming system, the world's fastest way of running 3D data over the internet. And we did a demo with thousands of people all over the world where we said, here's a website, you can log in, and they were able to stream without any plugins. We rebuilt the whole thing in Google Chrome using whatever pieces we could find. We rebuilt the whole unlimited detail engine. And this is probably coming out a little bit later as a whole huge range of products where people can copy the real world and then have like a little window on their website where you can just move around in real time. So there has been live demos before. And I think for the people who are more interested in the game side, we probably do some of those. Yeah, we need to do something for them. We've fallen a little bit behind in that.
I mean, to me, it is, you're trying to attract fundamentally the most hard-headed group of individuals that I have ever had to deal with, right? Is like the enthusiast, the PC gamer, the person who kind of understands technology to some degree, but maybe not a fantastic degree, but then, refuses to believe that these changes are possible, that these technologies are possible. I was one of those people at first too, right? And it takes convincing to show that that's the case. And, like I said, you show some snippets of that in the new video of, just interacting with the environment, interacting with creatures, shooting them, butterflies, whatever it happens to be. And I think it would be really beneficial to kind of push things along as if you had something like that to go along with your explanations in your videos and your technical write-ups, for sure.
Yeah. Obviously, I think if I was not part of Euclideon and I saw the claims that were made, I, of course, the same way am going to say, scam, that's a scam. And I would be annoyed. Like for example, I'm in hologram technology. I see things like the Michael Jackson hologram in New York, which was a projector on a piece of glass. I say, if you shine that projector on the wall, we call that a Michael Jackson movie. You shine it on the piece of glass, and suddenly all these people are saying, oh, you have raised him from the dead holographically. You are playing God. What an abomination. And I'm like, a hologram is is something that you see from all sides.
Right.
It's the Greek word, whole picture. And so I see a lot of this projectors on a piece of glass, flat as paper. They go around with people going, look at this high-tech hologram. Tony Robbins uses a hologram. It's a projector on a piece of glass. It's not like what you see in a Euclidean hologram room. So I know what it is to be on the other side, where you see something and you go, that's a scam. I know that can't be done. But in this particular case, we're innocent. And as much as we're not running a religion here, we don't need to convert anyone. We can just keep going forward, making technology, releasing it slowly, and people go, oh, okay, I was wrong, without us really doing anything. I do feel like if I was a person on the other side that thought this wasn't real, but I was wrong, I really want to know as soon as possible, rather than be fighting against people who are actually innocent. So we do owe it to some degree to give out a certain amount of proof that that this technology really is here now. And I think as things progress, just like in the geospatial industry, where to some degree, when you've got the major players, you look like you're on the road to saying that industry is we've won there now. Right. For games, a much, much, much harder battle.
Sure.
But I still think the time might come where there isn't any choice but to move to either us or something like us. Polygons, well, they're great big sort of flat things. The world is not flat, but it's round. So to make things more round, polygons must get smaller and smaller and smaller and smaller. When your polygons get down to only being like 1 or 2 pixels on the screen, you go, wait a minute, polygons had a use-by date. This doesn't make any sense anymore. If we're that small, there's no point in putting textures on them anymore. If your textures are down to 4 by 4 pixels each, things like that. So at that time, you say, we have to swap to a more atom-based system because our polygons are virtually acting like atoms anyway. So are we the future? Either us or something like us. Logic says one day your polygons got so small, they no longer, they destroyed their own purpose.
Well, I do want to say that I'm extremely jealous that none of these holoverse hologram rooms exist over here in this country. So let me know as soon as they come over here, or maybe I'll have to finally take that trip out to Australia that I've been wanting to do for a couple of decades and go see it.
It's so much fun. Come play with our toys. It is definitely something you have not seen before.
It sounds pretty interesting and compelling. So if I wanted to ask one final question of you here, it would be, what should our readers and viewers expect from you next? What is the next thing they should expect to see come from you guys to look forward to either go further down that step on the gaming side or the VR side or both?
Well, one of the things is Holoverse out here, our entertainment center, has obviously been a really big success. If it works in one place, we expect it's going to work in every place. So we will be moving as fast as we can to open up holoverses everywhere.
Okay.
Our aim is to make them like the movie theater of the future, where you and your friends turn up, you all go in a hologram room, the walls look like they disappear, it looks like you're outside. Suddenly you're riding on a holographic dragon with flapping wings, and you fly around and have big dragon battles in the sky. And I throw fireballs at you, and you get angry, so you summon your army of monsters and send them all back. Stuff like this. This is the sort of thing that this is the next level where games progress to. For us, there's pursuing Holoverse. It's a nice little niche market. No competitors, no one else to worry about there. So that's all ours. Then on the game side, I think we do sort of owe it to everyone at some stage to release some sort of game engine. And we've got all of that. We use it all the time. But packaging it up in a final way, I think we want to work with a few partners, first of all, who are in the games industry, just to get things exactly right. They don't necessarily have to be super big. They can be smaller ones. Whether we do or don't go into helping VR with their screens over their eyes geometry problems, I think that probably comes down to the moment I'm putting out an invitation. Any of the companies in the 56 of you from our present count. Some of you are a bit smaller. We don't mind working with smaller. Smaller is like little boats can move quickly.
Sure.
Big companies like big ships, very hard to turn.
Yeah.
But an invitation being put out there. We've got some ways to solve some of the problems in virtual reality helmets. If anyone wants to work on us on that, we're happy to do that. But yeah, at some stage, we want to release some sort of game engine where everyone can be creative and use all the things that we use.
Very cool. Well, Bruce, I do want to thank you for taking time on your Saturday to join me here for this discussion. I'm very interested in this. I've been interested in it for a while. I'm more excited now that we're seeing products out using it, and the possibility of getting a demo or an SDK or an engine out there in some capacity to mess around with. So thank you very much again for joining us, and good luck with the rest of the project, I guess.
Thank you, Ryan.
Thanks. If you enjoyed this content, consider supporting in-depth technical content by contributing at patreon.com/PCPer.